Good afternoon, everyone. My name's Jim Kaplan. I've got a lot of words next to my title, but let's just say I'm an engineer. And this year, I celebrated 30 years as an engineer, and I just wanted to share a few things that I've learned along the way in those 30 years of engineering. But before I do, one thing that I think is most important that I've learned is it takes a lot of different kinds of engineers to get a project done. In fact, I was driving down the street the other day, and I went over a bump in the road, and the car stopped. And so the first engineer that was sitting next to me, he's an electrical engineer, he said, well, you bumped it, the electrical line came loose, and we couldn't get ignition. Chemical engineer said, no, when you bumped it, you got some dirt in the fuel lines and we couldn't get combustion to go. And the mechanical engineer said, no. When you hit the bump, you dislodged the drivetrain, and so you couldn't get locomotion to the wheels. And then the software engineer said, hey, I don't know what happened, but let's all get out of the car, get back in, and see if it'll go again. So I take a jab at the software engineers because I'm one of them. First, let me tell you, with this top 10 format of top 10 things, it's a blatant ripoff of David Letterman's top 10 lists format. So I'm telling you right now that I stole his idea. And I think good engineers steal good ideas too. So, number 10, in this day and age, we talk about affordability of solutions. We want them to be cheap. We want them to be fast to market. We don't want to have a lot of time spent on them. Nobody has patience to wait around. And so we talk about something called an 80% solution. And oftentimes people get confused as to what's an 80% solution. If this is a 100% solution, the Cadillac, that's not an 80% solution. That's not going to drive. But maybe the Chevy's the 80% solution. Why do we say that? Maybe it doesn't have all the bells and whistles that the Cadillac does, but it sure can drive, and it can do the whole job of driving your car. And so when we talk about cheap and fast, that might be the way to go, cheap and fast. That certainly isn't. Number 9, one thing I tell people is always test early. And we're doing a lot of that out here on the floor. We build things and we're testing them, and we know what works and we know what doesn't work. One of the problems that we run into is when we wait till the end of our project and we start our testing, well, it's too late. There's too many things that we have to discover. If we could test early on in the process, we know what the problems are, we could fix them, and we could still get our projects out. I talk about this because in some of my past, I've done aircraft and avionics. And one of the places you have to test your airplanes is in the air, as we see down there, right? That's one of the worst places to do some of your initial testing. It's an uncontrolled environment. You never know what it's going to be like. It's always better to get as much confidence in your labs, figure it out on your bench, figure it out at your desk before you go into the tough environment. I wouldn't want to test my robotic air vehicle for the first time out here, right? I want to test it in my labs or on my bench a lot sooner. And something that goes with that too is start building as early as you can. And we talk about agile processes where we build a little and we get it out real fast. We have very fast turn times. Why do we like that? Well, when we build fast, we can get feedback on our product much sooner, and we can also start to get runtime on that core product. And as we add more and more and more to it, that product becomes more and more stable. We know what it's all about. So we're going to get done a lot more quickly, a lot more efficiently, a lot less surprises than if we wait around. When we build projects, sometimes we're lucky enough that it's just our project, nobody else's. But more often than not, we're building something that fits into a much larger project, a much larger product. If we look at something even like this robot next to us, there's a lot of things that go into it. The person building the engines on that or the electronics on that isn't building the complete system. It's the entirety of it. How does your piece fit into it? And it's important to know, when do you have to be done with your part? What are you going to expect for your part? What are the resources that you're going to have for your part? So important to understand how you fit into the big puzzle. More importantly, it's important to know what functionality you have to have. Let's say I have an early release of my electronics. Do I have enough so that they could start the thing up? Do they have enough that they can turn the lights on, that they can work it? I need to understand what's needed when, if I'm going to be able to be successful in not holding up the whole puzzle and understanding how my piece fits in. Number 7, pay attention to what other people are saying. And I think this is one of the most important lessons I've learned over my career, is when one of the people on my team comes to me and says, Jim, we've got a problem, or Jim, that's messed up, or Jim, it's not coming together. I may not want to hear it, but I got to listen to them. And it's important. We say where there's smoke, there's fire. If someone's telling me in my project that it's going to be a problem, that it's not going to come together, I better pay attention, because it's going to happen. And, you know, on some of our fun projects that we do, we just build them for ourselves. But when we're building serious engineering projects, when we're building buildings, when we're putting airplanes, ships, submarines, spacecraft up in the sky, those have to be incredibly safe, incredibly reliable projects. And so oftentimes when we're building projects like that, there'll be additional scrutiny that comes on us. There'll be independent reviewers that look at what we're doing. There will be people who come in and they want to look at every single equation along the way, every single calculation along the way. They want to make sure that we've got it right, that we're not going to endanger anybody along the way. I'll tell you, I went through some of that in my own life, particularly in aircraft and avionics, and the thing that we learned was we had a lot of people that were giving us a lot of extra scrutiny. You know what? Our design held up to everything they looked at. We didn't end up changing anything. So a good lesson is a good design will hold up to these additional reviews that you have. They'll hold up to the additional scrutiny. So always remember, when you're building something, build the best you can build. Build it for those kinds of applications where there's safety involved, where there's people involved. It's got to hold up. It's got to be good. This is almost a corollary of what we just talked about. It's, if it doesn't seem right, it probably isn't. And I tell people, I trust my gut. If I'm looking at something and it just doesn't seem right, you know what? It probably isn't. And I bet you all have experienced that one time or another. You're looking at something and you say, that doesn't look like it's going to come together, or what you're telling me doesn't sound quite right. If I'm hearing that, I want to make sure that I'm really asking hard questions and making sure that the projects, that the people are doing the right thing, that the projects are going to come together. And I'm not just going to take what they're saying for granted if it doesn't sound like it's the right thing. So definitely want to make sure that you trust your instincts if something just doesn't seem right. How many of you have ever experienced something where you just said, yeah, that's not right? Yeah, you know what I'm talking about. So it's okay to ask. It's okay to ask questions and challenge it. Doesn't mean you have to be mean about it. Just means you need to ask questions and make sure that they're doing the right thing. Number 5, what engineer would ever say it's okay to crash? Well, I do. My boss does too. When we build experimental planes, when we build experimental systems, it's okay to crash. It's all right. You don't like it, but I'll tell you what, if you're not having a crash occasionally, it means you're not trying hard enough. You're not changing things. You're not pushing the technologies enough. I'll bet you that there's a lot of things around here that the first time that we tried it didn't work out so well. Maybe the second time, maybe the third time didn't work out so well. Doesn't mean that we fold up and walk away. It means we figure out what we did wrong, we figure out what happened, and then we go forward. Now, when we talk about a production program, an airplane United Airlines is flying or Southwest Airlines is flying, it's not okay to crash. So only when we're in a development program can we do that. But once we worked out and done all our testing and ensured that we built a safe system, then we're good to go and let people use it in the real world. In economics, there's a rule that one of the number one rules of investment in economics is what you invest going forward has nothing to do with what you've invested so far. It's what do I have to spend from today forward? I say that same principle applies into our engineering activities. And why do I say that? How often have you worked on a project and it's just not working out? You've tried and tried and tried. It's just not working out. Yeah, it's happened, huh? Sometimes you need to say, instead of saying, you know what, I put in so much time and energy into this, I'm just going to keep putting in more and more and more. Sometimes you have to look at it and make that hard decision and say, maybe I need to put this one on the shelf and go on to my next project. That's okay too. But don't use the criteria of, I've spent the last year working on this, so I got to keep working on it. It should be, what do I have to work on from today forward? How's it going to be? How much work is it? Is it possible? Or is it not possible? Should I be working on something else that's going to be more fun? Something else that's going to get me a lot more satisfaction? So think about not so much what you've done already, but what you're going to do going forward. Number 3, every project has a big problem. So this sounds like I'm going exactly the opposite of my last statement, but sometimes you have a big problem and you got to deal with a big problem. I had a big problem when I was doing a large project for an aircraft program. I was putting a new cockpit in the airplane, and guess what? My display manufacturer went bankrupt on me. What am I going to do now? I'm building a cockpit that looked just like this. And where the displays go, all I had was holes. I didn't have displays. And so this was a huge issue, not just for my program, but for a lot of programs. What did I do as the lead on that project? I worked hard to find another supplier, and then I went to the other programs, the other 4 aircraft programs that had the exact same problem I did. In some cases, they were my competitors. In some cases, they were international partners. But what did I do? Instead of thinking about the business side of it, I thought about how do we cooperate? How can we make one common specification, split the purchase between the 5 of us, so instead of my program having to pay $10 million and 4 other programs having to pay $10 million, we split it between 5 programs. Each program had to pay money. Yeah, it was $2 million each, but that was sure a lot better than $10 million each. It was interesting because this was a U.S. Air Force program, and the Air Force recognized me. I was lucky enough to get an award from the Pentagon for saving the taxpayers' money. So the message there is, when you have hard problems, be creative. Think about different ways of solving them. Think about the engineering excitement of coming up with a solution that solves 5 problems instead of just 1. And oh, by the way, sometimes you get a real reward for it too. This one is probably, I think, the most appropriate lesson I've learned, and it says, you don't have to have 30 years experience to have good ideas. Every one of you has got a good idea. Everyone in this room has a good idea. And so I'm asking you, bring your good ideas forward. There's so many awesome ways you could build great projects. There's so many awesome things that you can do and you can contribute and build something. That's why I love what the makers are doing. They're all building things. It's very, very cool. I wanted to also, you see it's cut off here of who said this, but Thomas Edison said it, that genius is 1% inspiration and 99% perspiration. You spend a little bit of time being a genius in your mind, and the rest of the time you're sweating it out and working it hard. So work it hard, build things, bring your great ideas forward. And you know what? I've talked about some technical things, but I just want to share one thing with you that I learned the hard way, and I don't want anyone else to have to repeat. When you're sending an email, always read it before you hit the send button. I had a couple of examples over the years, and in one case, I wanted to let one of my suppliers know where I stood on a technical issue. And so I had written a note to one of my engineers and said, hey, give me the background on this. These guys are going to try and weasel out of the problem. So then I took that same response back with all the details in it. I decided to edit his response because it was a little bit rough, and I sent it to my supplier. Oops, I kind of forgot to take out the part about calling my supplier a weasel. That didn't put me in a very good negotiating position, and I was pretty embarrassed when I had to start off with apologizing to the guys. But always take a look at that. Another one is, don't hit reply when you mean to hit forward. That happened too. It was forward to someone else to say, hey, is this really right, or does this guy just kind of make up this data? Oops. Hit reply. The guy saw the message. Uh-oh. Okay, so don't make that mistake. Don't make that mistake. Always look at your emails. Always have fun. As I leave you, let me just share one last thing with you. Always find a mentor. Always find somebody that will help you out, that you can run ideas by. Always find somebody that can, that you can just go to lunch with and talk about things. It might be a technical issue. It might be a personal issue. You learn all sorts of things. Find somebody that you like. Find someone around you, whether it's at church, whether it's at school, whether it's at your parents' company, whether it's in your own company, wherever it happens to be, find a mentor. These people can help you out a whole lot. I've been blessed with a lot of mentors in my career that have helped me to be successful. I don't claim to have it all figured out, but I did want to take a few minutes and share some of my lessons learned with you today. Thanks for being here. Thanks for being involved in STEM and Maker, and for making this a great day.